Hi, good morning and welcome back to day 2 of the Space Summit Conference. This is powered by the Design Terminal and it is also hosted by Europe. This is a Horizon 2020 project. Now, just to remind you, the whole purpose of this summit and this conference that we're doing here is to connect with different experts all involved in space technology. Academics, people in the sciences, business people who are looking and seeing this as a whole new opportunity and trying to bring these people together to create a new network and also ultimately to inspire the next generation of space tech startups. Now, yesterday afternoon we had 3 panel discussions, very intriguing topics that we were looking at. The first one was focusing on how space technology is actually helping us avoid the climate crisis here on Earth. After that, we looked at how that space technology is integrated into our everyday lives. And then finally looking at space as an industrial zone, a new industrial zone. Now this morning, over the next 2 hours, have a slightly different approach. The first hour, we have 3 experts who will be talking here, one after the other. And after that, we'll be back for another hour. And this is the opportunity for you to see 6 startups in action. It's going to be a pitch battle, and these 6 startups are going to be pitching their space tech ideas in front of a jury, and there is a prize for the best startup. Before that, we have a series of expert speakers who are coming on here to talk and take us deeper into their own particular areas that they're working on within the space tech industry and academic side of things. First up, we are looking at space communication and how that's affecting communication here on Earth. We're going to look at the life of an analog astronaut, and finally, the whole concept of whether space can be used almost like a new tourism. But let's look first, this first aspect of communication, because I think as we learned yesterday, that seems to be one of the biggest influences space tech is having on our lives. And I'm sure you're sitting there watching this whole conference on Zoom. And like most of us around the planet, a lot of your work over the last 18 months took place via Zoom, Skype, Microsoft Teams, these kind of platforms. And it put a huge pressure on networks around the world. Sometimes it was a success, sometimes it wasn't. But we know that this digital communication is going to expand and grow. And it's got to move somewhere and change to be able to adapt to that. And that's what our next guest works with partly, and also is deeply involved in the whole concept of communication in space and space engineering. So I'd like to welcome Laszlo Csurgai Horvath. He's Associate Professor at the University of Technology and Economics in Budapest. As I mentioned, has this special research topic at the moment involved in engineering aspects of space technology. So good morning, Laszlo. Thanks for joining us.
Good morning.
And actually, one bit before we get into, because it'd be really interesting to hear about the research you're doing and get some insight into that, and then look at how that is connected to the world of communications. Before that, one thing that I would personally like to ask you is, Hungary is a small country. And we know that a lot of the technology that's going to be actually developed, if that's going to be something that's going to be usable, it's going to have to be mass produced, and that takes a lot of money and a lot of investment. So I was wondering, as a potential industry, space communication, how useful could that be to Hungary? How important could that be to Hungary in the future?
Yeah, it's an important question. So as you mentioned, we are a small country, and the space communication is really a very important part of any spacecraft. And we should distinguish different space missions. Probably the main difference between missions is that one is a commercial product or a commercial satellite, and the other big field is a scientific satellite that performs scientific measurements and so on. So I think so that because Hungary is really a small country, so mainly And as we have done also during the past, we participated in scientific missions mainly. So anyway, there are companies in Hungary who are manufacturing communication parts for commercial products as well. But I think so that the main way is the scientific satellite. Yeah.
Right, and if we can come back a little bit to the work that you're doing, especially this current research on the engineering aspects of space technology, just explain that to us and how that connects to this scientific side of space research.
Yeah, so we are dealing at the university with scientific satellites mainly, and we are teaching also to the students that satellite communication is a real important part of any spacecraft, and the communication equipment on a satellite is one of the most important part, because satellites cannot transfer data without communication. So this is why it's really important. And the question is, how can we transfer data from a satellite to the Earth and from Earth to satellite? So as I mentioned, mainly we are doing it with radio communication, but there are other technologies. Probably everyone heard about light communication, usually performed with laser beams. This is also a technology. So from satellite to Earth or Earth to satellite, laser communication is also applicable. And the third one that is really important, and now it's an emerging technology, is quantum communication. That is a very different thing, and it is under development. So anyway, this three type of communication is important, but mainly the radio communication is what usually we are working on.
Right, and what are the kind of challenges? Because obviously this is something that constantly has to be developed, as you said, and the communication between the satellite and other factors is the key element here. So what are some of the challenges that you face? Because obviously up in space is different to down here on Earth. That would be really good to hear about. Why it's so essential to develop this radio communication to overcome those challenges.
Mm-hmm. Okay, so there are some big differences between terrestrial communication and satellite communication. The main difference is the distance. So probably everybody knows that the satellites are very far from us. It is not always true, but depending on the orbit of the satellite. But in real life, mainly everybody knows that there are broadcasting satellites. So when somebody has a satellite receiver at home and a satellite receiver dish on the roof, then he communicates usually with a geostationary satellite. That distance is 36,000 kilometers. So it's quite 2 times big as the diameter of the Earth. So they are really very far. So this is one challenge, that the distance is high. The distance is not always high, of course. There are low orbiting satellites that are much closer. So like the International Space Station is much closer. But anyway, the distance is one problem. The other key issue is that the radio signals from the Earth up to the satellite are traveling through the atmosphere of the Earth. And in the atmosphere, there are meteorological effects. There is rain and wind, and the temperature is changing. There is a fog. Clouds are moving. So this is one of the biggest challenges, because now the key issue is that satellite communication goes up and up in a frequency range. There are many reasons of that, but the main reason is that now the radio communication needs more and more speed, more and more bandwidth. And for that one, we cannot do anything but changing the frequency up to the higher regions. in order to clarify this, that satellite communication now works up to around 20-30 gigahertz. And, but now there are researches also supported by the European Space Agency and by NASA and other entities to go higher and higher in the frequency range. And the key problem is that when we applying higher frequencies, then the atmospheric effects are more influencing the communication. So this is one challenge. The other challenge is that if the spacecraft is very far from us, let's say it is not an Earth orbiting satellite, but a deep space radio connection must be created, let's say during a Mars travel or other missions that are much farther than our environment, then the distance is much higher, and it is also a challenge. Yeah.
Okay, and you know, obviously you're working on overcoming some of those challenges. How does that, you know, what does it look like? Because obviously as soon as you say to somebody, you know, a sort of, you know, person in the street, this is somebody who's dealing with space, you know, technology, communication, you know, with people who are involved in space travel or within satellites. We think about that physically, but my assumption is that probably you're doing a lot of modeling to look at how this works. So what's, you know, in a way, what's the daily life like at the university? You know, if you're working with a team of students on this research, how do you go about it?
Yes, so as I mentioned, we need to go up with the frequency. Right. This is one possibility to increase the speed of the communication, because now everything is faster. So not only the communication, but everything is faster. So radio communication must be also faster. So what we can do is, the new challenge, or one of the challenges, is using high frequency electronics. That is not so simple. So when we go up with the frequency, then the devices are really very expensive and very sensitive, and it is not so easy to work with them. So this is one challenge. The other, what I mentioned, is that the atmospheric effects are very intensive in higher frequency ranges. So this is also a new research area. What can we do if the atmospheric effects are influencing the communication line? So here on the Earth, we can also observe that sometimes we cannot use our mobile phone when there is a heavy rain around here. So, and this is also in satellite communication, and it's a big question, what can we do? So one issue that is intensively researched is adaptive communication. That is, maybe this word is a little bit more technical, but adaptive communication means that the radio communication system tries to observe the environment and change the type of the communication when there is some external influence. That means, for example, when raining is started, then we need to reduce the speed of the communication. Otherwise, we completely lost the radio communication line. And the worst case is when we lost totally the communication. That should be avoided. So adaptive communication helps to keep the radio communication under bad weather conditions as well. Nevertheless, the speed may be reduced, but we will have still communication, and that's a new challenge. And maybe if I have some time for that, yeah. What is really important now, using artificial intelligence in radio communication, so that now artificial intelligence is everywhere applied, so it's a new buzzword. Anyway, but how can artificial intelligence help in radio communication? So it's a complicated question, but we are dealing with this at the university. Roughly, we can say that there is an intelligent management system that is checking the radio communication line in real time during the communication and changes the parameters in order to have the maximum bandwidth and the maximum speed. Okay, so briefly, that's it.
Right, yeah, but it gives us a very good insight into it, and also, as you said, you know, the sensitivity and the expense of some of this equipment that you're working with. Just staying on this, just one more question around this whole subject of space communication. Is there a limit, to how far that radio communication can actually travel? Because, as you mentioned, we do know that there are, there are rockets, we've got travel going into deep space, and we've got things that are moving continuously. What is the limit at the moment?
Yeah, it's a really good question. So we are teaching this at the university. So practically the radio waves are attenuating when they are traveling in the space. But probably everyone heard about the Pioneer missions and the Voyager missions. They already left the edge of the solar system. So now the Voyager 2 is already out of the solar system, and still there is a communication with this. So how can we imagine this communication? So when the spacecraft is very far from us and the electric power is limited on the spacecraft, that means that he cannot transmit with megawatts of radio transmissions, of course, so it has only a small power radio transmitter. Then how can we receive this very weak signal? This is a question. One possibility is to increase the size of the receiver antennas. So this is why you may see a huge antennas, 20, 30 meter or even bigger, to receive such a deep space missions. The other issue is that the distance, the power of the radio signal and the noise added to the signal are in close relation. So when we decrease the speed of the communication, then we can communicate with a very far equipment also. So here is a close relationship called, this is a Shannon equation that describes this one. So practically there is no limit with the distance. So this is the final conclusion, no limit, but the speed of the communication will be lower and lower when the distance of the spacecraft is higher and higher.
Okay, and just to give us an example of that, so with Voyager 2, currently, if it's sending a signal, how long does that take to get back here on Earth?
Oh, it's a nice question. So as far as I know, the distance of Voyager is now more than 100 times of the distance, 100 times the distance of Sun and Earth. That means that, the radio signals are arriving from the Sun to the Earth approximately within 8 minutes. Then please multiply 8 by 100,000. So that means that 800,000 minutes when the signals arriving. So that is more than 1 year, I think so.
Wow. Okay, so that's currently that's the time it takes. Okay, it's very interesting. And there is some, before we finish, I do want to get onto this topic of, so how do you see, all this research, and as you said, it's scientific, but there's always a connection between the science and the commercial side. how do you see the communication changing, especially digital communication changing here in, on Earth, using some of this new technology that is happening? I mean, what do you perceive is going to be happening? What do you imagine is going to be happening in 2, 4, 5? What's the future?
What is really a new technology or an emerging technology is now that satellite communication for 5G and 6G. Mm-hmm. You know that mobile communication systems are trying to move to satellites. This is one that will be applied in the future. So 5G and 6G everybody knows that it is a new mobile communication standard. One of the key issues is the low latency of the communication. That means that the signal traveling time must be low. And it is not so easy to support this by satellites because for a satellite, because the distance is high, the radio signals are also traveling a few milliseconds or seconds even, so that is a challenge. And probably everyone heard about the Starlink project, when many satellites are launched in order to support internet connections. So Starlink is good because they are low orbiting satellites. That means that the distance of the satellites are only a few hundred kilometers. Let's say around 500-600 kilometers. That means that the latency will be very low. So they are very close. The radio signals can travel very fast during this. So I think this is the new era of the development. And it has also a strong relationship with the commercial application, because the stock market requires high-speed communication. So this is leading very far from here. But I think the main issue why Starlink has been generated or is created is because it will support the stock market in order to change very fast the prices of the stocks.
I remember reading once about a high-speed fiber optic line that was put down somewhere to just increase by a few milliseconds.
Yes.
And the profit from that is phenomenal. So I can understand that. So it's quite an interesting idea where the interest is coming from this. Laszlo, it's been very, very interesting insight, into how, your world and the research you're doing. I want to finish with one question. It probably sounds very, very simple, but you're involved in space communication. You've obviously seen what's, you've got a perception of what's happening up there. What's your belief? Is there life out there?
You mean a life in the universe?
Yeah,
somewhere?
Another intelligence. You picked up any signals?
Yeah, I prepared myself for this question. So, okay, so it's I'm do not dealing with that one, but I have my own opinion about this, so maybe I can share it. So up to now, it seems that anyway. So now we can say that the technical civilization here at the Earth is very young. So we may say that only 100 years is the age of the technical civilization here at the Earth. If we consider the whole universe, then there should be other civilizations with much higher maturity. So that means that there should be civilizations, or there may be civilizations with 1,000, 10,000, or 100,000 years of maturity. The good question is that why they did not contacted us up to now. So it is in my mind that one reason is that because they cannot reach us because the distance and so. The second is they did not found us that it would be also possible. And the third one is that they are already here, but we cannot see them. Okay, but it is all in my opinion. So
good, but it's a wonderful thing to finish on there, especially the fact that maybe they're already here, we just can't see them. Thanks very much. Very interesting insight into your research, the future of communication, and the kind of challenges you're dealing with. Thanks very much then to Laszlo Csurgai Horvath. Thank you.
Thank you very much.
Thanks. And
Thanks.
we'll be taking a short break now, and then we will be back looking at the life of an analog astronaut.